Hello everyone, thank you for joining us for today's XenApp and XenDesktop Tech Update CUGC User Share webinar with Daniel Feller. My name is Brad Hornback and I work with CUGC HQ. Before we get started, we're going to quickly review format of the webinar that we're going to have today. The presentation will last approximately 25 to 30 minutes. We might go a little bit longer than that today. We have some really good content for you today. And then following that, for the remainder of the time, we'll have a Q&A and discussion. If you have any questions along the way, please use the question area in the GoToWebinar panel. Once the presentation is ended, Daniel will get to as many of the questions as possible. Just so you know, this webinar is being recorded and will be posted on mycugc.org in the coming days. That way, if you want to review it or share it with a friend, it will be there. Our presenter today is Daniel Feller, Citrix lead architect, desktop and apps group. We know everybody is really looking forward to his presentation, so we're going to go ahead and turn it over to him and get started.
All right, so there we got the webcam on. So yes, it's volume 7 of the tech update. For those of you who are new, this is the 7th time I've done this, and each time there's always something new that's added. And basically the whole point of this is that there's a lot of things that are going on, a lot of things that are being updated and released, new best practices around XenApp and XenDesktop that it's hard to keep current just with how fast things are coming out. I mean, Citrix is releasing a new version about it seems like every 3 months. So that's kind of the whole basis of this tech update, is just to kind of get an understanding of all these new things that are coming out very quickly. So let's just get right into it. Basically, if you haven't heard, this is 30 minutes, and I have about 76 slides, I think. So you basically want to hang on, strap yourself in, because it's usually one hell of a ride. But all this information that's in here, I don't create it all on my own, because it's a lot of work. So again, we thank everyone at Citrix and outside of Citrix who have helped provide the details. See, this is much better when it's live and I can hear people, because usually I get a pretty good laugh out of that thank you slide. So it's a little unique doing this online like this, where I don't get much feedback. But I do see some of the comments in the questions, so that's great to hear. But the agenda, as you can see, there's quite a few things, so let's get right into it. First thing is HDX, and basically I like to think about HDX as nothing's impossible. If you've been using like XenApp and Presentation Server years ago, I had friends that helped me implement MetaFrame 1.0. And they've kind of been away from the Citrix environment for a long time. They're seeing like video and voice and all this thing happening over XenApp and XenDesktop sessions. It's amazing what's capable now. What's possible. And it's all based on the different types of technologies that are being used. So you can do LAN, WAN, and mobile networks, and it's all because there's lots of different ways that we can transport that data across the network. You can compress it, you can do remoting, video streaming, image caching, and the new one is user intent. At least that's what I call user intent, and this is really the frame hog. Basically, if you can think about it, is that as your latency and bandwidth increases and your packet loss increases, you start to get like runaway scrolling in a browser or in Excel. So you hit page down, nothing happens. So you hit page down again, nothing happens. So you hit it 5 or 10 more times, and all of a sudden, your browser just goes crazy because it's doing all those page downs that the system finally received, and it's sending all those page down results back to you. So what user intent does in FrameHog is that everything happens the way it was before. You keep hitting page down, nothing happens. And so you keep hitting it constantly. Eventually, the system's going to catch up and start sending you the screen updates. You'll reach a point where you will see the info on the screen that you want to see. You might have the screen might have come down and page down enough, so you stop hitting page down. Well, with FrameHawk, it's basically going to ignore all the other page downs that you have sent that the system has not processed yet and not sent you the responses yet. So it just kind of throws all that information away. And so that's really how the FrameHawk, part of the FrameHawk technology works, is this whole user intent. It understands that you stop hitting page down. That means what's on the screen is what you want to see, so I'm not going to send you anything else because you'll be beyond what you're interested in reading. But again, you know, when you look at the ICA connection, there's lots of what we call virtual channels, lots of things that are part of it. And you know, they do multimedia, they do flash, they do drive mappings, and there's a bunch of different ones for, you know, the graphics, you know, how your screen looks. You know, it's FrameHog, DCR, ThinWire, H.264. The thing here is only the techies like talking about that, you know, like talking about ThinWire and what ThinWire does. But a lot of us, you know, even myself included, I tend to have trouble remembering that, okay, H.264 does this, this is how it processes it. So there's been policies built in, template policies built into the latest versions of XenApp and XenDesktop that basically are use case specific, that says, if you're concerned about user experience, use this policy. And underneath, it's actually going to use the H.264. If you're interested in server scalability, then you want to use this policy, which will use ThinWire plus do some other things, you know, on the back end to help increase server density. If you're on like a WAN or a high latency or high packet loss environment, it'll turn on FrameHog plus do a few other things to optimize it for that particular type of use case. So it's not that you need to understand the technology behind it, but at least start with those type of policies to get you started on the right way to build to design your policies. So with the latest release, with XenApp XenDesktop 7.7, we wanted to look at some scalability testing of how many users can we get on a server. And so again, we're going to start with Windows 7 because honestly, Windows 7 is going to be one of these, you know, who wants to live forever type operating systems. It's going to be around here for ages. So we're going to keep looking at this. And we want to look at across all the different hypervisors. And for this test, we're looking at machine creation services versus provisioning services using the disk caching approach. And what we end up seeing is that XenServer and Hyper-V, you know, it's very close on MCS, and then PVS, it actually dropped a little bit. But again, XenServer and Hyper-V results are very similar. I do have, before you ask, I do have vSphere numbers. I am not allowed to share them with you on a public format like this, but if you ever see me at a conference, feel free to ask me and I'll tell you. But honestly, the numbers are very similar. The percent differences between all the different hypervisors were the same. There's just a little bit of variation on, you know, which one ends up with the highest density. So in this case, if you look at MCS PVS disk cache, MCS clearly won. But with some of the latest things in PVS, people are moving away from the disk caching technology. And so now we look at PVS disk cache versus PVS RAM cache. And what you now see is all of a sudden, you know, with the RAM cache with Windows 7, we started getting a little bit greater density on our servers. So now let's look at PVS RAM cache using the user experience Citrix policy versus using the scale policy, you know, maximize server scalability. And here it's a significant increase. You know, it went from, what is this, about 105 users up to about 142 users. I mean, that's massive on Windows 7. And that's just by using the Citrix policy. That's turning the Citrix policy from user experience to scale. And that's all that happened here. So now let's take the scale policy and compare it to the Citrix WAN policy. And again, we wouldn't expect to see a major difference here. These two policies are doing very similar things from a CPU perspective on our server, but the difference here is that the WAN, when you do the WAN policy, it's going to end up sending less data across that link. So there'll be a little bit more compression that's going on, but not to an effect that's going to impact server density that much. And then finally, all these tests so far, we've used the default OS configuration, you know, unoptimized. We haven't turned any services off, haven't changed any scheduled tasks. And what we end up seeing is that when we optimize the OS, we get another little bump in density. And again, just like you would expect, because there's less things happening with the environment. So we want to look at this to compare Windows 8. Well, no one's running Windows 8, so we just kind of ignored that one and quickly moved on to Windows 10. And as we all know, there's a lot of speculation about how much is Windows 10, you know, watching you and observing the things you're doing. But you know, we'll go back through the exact same test format. So the first one, MCS versus PVS disk cache. So there's MCS and there's PVS. Just like we saw in Windows 7, when you went to PVS, it drops a little bit. And then we flipped on PVS disk cache compared to PVS cache and RAM. And again, it's about the same, maybe a little bump up, but it's negligible right now. Now let's looking at user experience Citrix policy going to the scale policy. And the same thing, what we saw in Windows 7 to Windows 10, the scale policy actually increases our server density, but not as much. And we'll talk a little bit more about that in a moment, why the density differences aren't as great. And so as we finish this up, we'll look at scale policy versus the Citrix WAN policy. And again, just like Windows 7, there really isn't much of a difference here. It's not impacting the CPU, but it will impact the network utilization. And then finally, it's the default OS config versus an optimized operating system config. And again, as you would expect, you start shutting down services, you get greater density. Now, what's interesting here is, all of the results were pretty much what we expected, when we compared Windows 10 different results and Windows 7 results. But we want to see what happens if we compare Windows 7 and Windows 10. And there's been third-party papers out there that have looked at this in a VDI environment, but we want to look at our own testing procedures just to see if our tests validate what we've seen from other people doing. And so the first thing we looked at is PVS disk cache user experience policy using a default operating system config. So this was different than what we saw everyone else showing, in third-party papers. We are seeing Windows 10 have a significant greater density than Windows 7. Everyone else that we've seen reports on is showing the opposite. Windows 7 edging out Windows 10 by about 5 or 10%. So we thought, okay, maybe this is just a fluke. So we flipped over to PVS RAM cache, leave the user experience policy as is, stay with the default operating system config, and the same thing. Windows 10 is outperforming Windows 7. So we kind of stopped the test for a little bit because we're like, we don't trust the data anymore until we could figure out why. And it really comes down to Arrow in Windows 7 sucks. And to validate this, the next test would validate it. When you flip on the scale policy, Arrow in Windows 7 is disabled. In Windows 10, you really can't disable Arrow. It's just part of the underlying system. But it's what we heard from Microsoft is it's better optimized. There's really none of the 3D flip. There's none of the usually the transparency is turned off. And that's what we typically recommend on a Windows 7 environment. So we went to the scale policy. All of a sudden, our results are now matching third-party papers. And the third-party papers, when we go back and reread these, a lot of people are looking at testing the operating systems when they are completely optimized and everything's shut down, regardless of the user experience. That just to see how many people we can pack onto a server at once. And again, so our results now, as we start optimizing the desktop, optimizing our policies, we start getting the same results that everyone else gets. And again, you go to the WAN policy and you go to the optimized OS policy, and again, Windows 7 starts edging out Windows 10 by a little bit. But again, we're talking about 5%, maybe 10% greater density with Windows 7 compared to Windows 10. And that's only if you go down with a scale policy, when you're ignoring the user experience. But when you're looking at the user experience, Windows 10 does significantly better than Windows 7. The next thing we want to look at is Office. So there's been many, so we've been doing these tests for a while. There's been Office 2010, 2013, now 2016. And what we see is that with 2010 and 2013, density decreased. And with 2016, it decreased even farther. So if 2010 gave us 100%, to estimate 2013, you got to take off 20%. If you're doing 2016, you got to take off 25%. So a lot of the sizing numbers you see are going to be based on Windows 10 because it gives you the best number. But based on which Office version you're going to use, you have to take that into account when you're trying to size your own environment. The next part here we would talk about is NUMA and COD. And so I like to say this is the for those of you who know Nick Grintalin, this is what I call his section. So he writes these really long blogs on the Citrix site, about NUMA. He loves talking about NUMA. And they're really long blogs, very complex, but they're really good. And he hates me because I take all this information and basically summarize it into 3 or 4 easily to understand slides. And he just hates when I do things like this. But it helps to understand, so you don't have to spend an hour trying to read and understand his blogs, just to understand how this will impact how you size the XenApp environment. So NUMA is essentially, if you look at a server, you're going to have so many sockets. You're going to call them how many processors you're going to have. Each processor is going to have so many cores. So you might have a dual processor 12-core server. And that's what this example is going to be. So what we end up seeing is that we have two processors. Each processor have 12 cores, so it's 24 cores total. And we're going to have so much RAM in the system. Now, the RAM is not evenly shared across both sockets. Each socket does a local memory access to a portion of the RAM. So part of all the RAM you put in there is going to be associated with one of your nodes, one of your NUMA nodes. And that'll be local memory access. That's the fastest way for a certain NUMA node to get to memory, is for the local memory access. But there's inter-socket connections between the different NUMA nodes that will allow a NUMA node to access memory that's on the other memory node. It still works, it's still fast, but it's not as fast as doing local memory. And so if we would size our XenApp environment with this, if we wanted to virtualize XenApp, how you would virtualize this is based on how your NUMA nodes are designed. Because you don't want XenApp VM to span NUMA nodes, because you end up losing server density. So this is a very simple example, one NUMA node per socket. What there's also we end up seeing is that you might have two NUMA nodes on a socket. So again, the architecture is the same, except you have more NUMA nodes. And this will impact how you design your XenApp VM specs. So again, there's still the whole inter-socket connections between everything, so they can all talk to the different remote access memory. But for optimally, you don't want to cross NUMA nodes. And so we did some bare metal versus VM testing on XenApp to see what we end up getting. And what's important here is you're never going to get better than bare metal, because the hypervisor is always going to add an overhead. What we end up seeing is that on this particular implementation, which was an 8-core server, dual processor 8 cores, is that the best density we got was when we used either 4 virtual CPUs or 8 virtual CPUs. Because this particular NUMA architecture was, each NUMA node was 8 cores. So 8 cores, of course, gave us the best. Or 4 virtual CPUs per XenApp VM also gave us the best, except we had twice as many VMs when you compare it to the 8 virtual CPU. So when you're trying to decide how to virtualize XenApp and figure out how many VMs you should have and how many virtual CPUs allocate to it, look at your NUMA node. If it's going to be, if your NUMA, either do 100% of your NUMA node or half of your NUMA node and double the number of VMs, and that's the best place to start. So this gets us to the fish, cod. That is apparently a picture of a cod. I have no idea. That's what Wikipedia told me. I'm not a fisherman, but you understand what the point of a cod here is in a second. So Intel on the Haswell V3 chips, they are 14 cores. One of them is 14 cores. They have numerous cores, different designs. But let's say we're talking about the 14 core here. So you would think it's going to be 7. The NUMA node is probably going to be 14, or you're going to have 2 that are going to be 7. Actually, one of your NUMA nodes is going to be 6, and the other one's going to be 8. So how do you virtualize XenApp on this? It becomes a little more difficult, because you go with 6, so you can keep everything in the NUMA node, but then you're wasting a couple of your cores, on NUMA nodes 1 and 3, or do you go with 8, and then you're hurting the performance when you're on NUMA nodes 0 and 2. So with the Haswell version 3, they have this whole thing called cluster on die. And essentially, it creates a cluster, as you would think, but it evenly distributes the cores across the NUMA nodes. So even though number 7 appears in NUMA node 1 and 3, the cluster that the processor creates for the NUMA node actually spans across the NUMA nodes and helped optimize the environment. So now, when you would virtualize a system like this, your XenApp VM, the best density you're going to get is a 7 virtual CPU VM. There's nothing wrong with an odd number of virtual CPUs. It works totally fine, and that's going to be the best implementation, the best density you're going to get. So if you take all these things into account, how does the policies impact us, users, how heavy are they using the system, Office, how much is that going to impact us, NUMA nodes, cores, all those type of things, how do you even begin to start thinking about sizing? And how we typically do it is we have estimates here for how many users per core, based on whether the user is going to be light, medium, or heavy, and the different operating system you're going to use. And of course, the heavier you get, the less users you're going to get on a server. So this is your base. This is going to be the best number you're going to get. So if you're doing Windows 10, I believe that's probably 13 users per core for a light user. So you take 13 times the number of cores you have. If you have a dual processor, 12-core server, multiply that by 24, and that's going to be the best number. Now you need to start subtracting and adding based on the some more characteristics of your environment. So that number is based on Windows or Office 2010. If you had antivirus, you basically got to drop 25%. If you had active monitoring, you drop 15%. Office 2013 would drop 20%. 2016 would drop 25%. But hyperthreading is going to add 20%. So you can take all these percentages to help nail down what your actual server density is going to be. We've used this quite a few times, and you actually get pretty close. You'll be amazed at how close you're going to end up getting to the actual number for your implementations. So for deployment options, there's a lot of different ways you can deploy this, and this is the typical. Those of you guys, have seen some papers I've written or presentations I've done. I typically use this whole 7-layer architecture diagram, and I'm going to use it again to explain the different ways you can deploy a XenApp or XenDesktop environment, and it comes down to the question of what do you want to manage. So you can do it on premises, and that means you manage everything. You manage the hardware, you manage the resources, you manage the infrastructure. And this is the way a lot of us have been doing it for a long time. Another way of doing it is do cloud hosted. So essentially it's the same architecture, except you don't manage the hardware anymore. You let someone else, you let Microsoft or Amazon handle the hardware. You still have to manage the infrastructure. You got to manage your resources. You got to manage your user rights assignments. But you don't manage the hardware. Someone else does that for you. The other thing you can look at is Citrix Workspace Cloud, where you don't manage the infrastructure. So the delivery controllers, storefront, the SQL databases, license servers, you don't have to manage that. Let Citrix do it. And they'll manage the hardware for those components as well. And then you will manage everything else, what matters, the users, the user rights assignments, the user resources, and maybe even the hardware to support those resources. And then finally, if you don't want to manage anything, you just go with a Citrix service provider and let them manage everything from end-to-end solution. They manage the resources, the virtual desktops, the apps, the infrastructure, and the hardware. All you do is you launch receiver and get your apps or desktop. So it essentially comes down to looking at all these different layers and all the different requirements in the tasks that you have to do, and figure out which one of these do you want to do. And once you figure out what you want to manage, what your IT team should be responsible for, that shows you which path you should go down. Should you be cloud hosted, Workspace Cloud, on-premises, or Citrix service provider? And that helps guide you into the right approach for your organization. One of the new things that was added recently to 7.7 was multi-site. So when we switched over to the FMA architecture in the 7.x XenApp and XenDesktop, what we end up seeing is that we had a requirement that basically we want to keep everything separate, site-based. And so if you had multiple locations, they would each be their own independent XenApp or XenDesktop implementation. They each have their own delivery controllers, their SQL databases, and all the resources. With 7.7, we now have the whole multi-site implementation. The architecture is very similar, except the delivery controllers at your satellite sites will talk to the SQL database at your primary site at headquarters. And there's been some optimizations done to help improve the how much data has to go across between the delivery controllers and the SQL databases. And based on this we get zones back. We now have zones within the FMA architecture, the 7.x, XenApp 7.7, XenDesktop 7.7, and beyond. So you define these different zones based on your sites. Each site, though, you still want to have a storefront server just so each site can be independent in case we have a network outage of our WAN link. And it also means that a user can connect to any storefront server and still get access to an app regardless of which site it's located in, which zone it's located in. Now, this doesn't mean you can make every site its separate zone. I mean, you don't want to have a site that has 10,000 users and you have a 1 megabit connection connecting to your primary zone being a zone. It should also be its own. And so some of the guidelines we have based on some testing is that based on how many concurrent sessions you have, you want to look at how many concurrent launches you need to be able to support. You know, the more number of users you have, chances are you're going to have to support more concurrent users. There's a minimum bandwidth you should have, and a minimum, you know, and also a maximum latency you should have. It's not going to break, you know, if you go beyond this. But what's going to happen is things are going to take longer. Meaning that if I have 60 concurrent launches happening at the same time, and my round-trip latency is 100 milliseconds, that means every launch is going to take longer than if my latency was 5 milliseconds. If my bandwidth is only 1 megabit per second, it's going to take longer than if my bandwidth is 8 megabits per second, because there's only so much information, so much data you can send through the pipe. So these are the guidelines to help you figure out when you go down the zone route in 7.7 and beyond, how big should your sites be and still be considered a zone? You know, what should that WAN length be between all those sites in order to give a good user experience? So part of this, you know, I mentioned that if the WAN link goes down, what happens? And this is this whole connection leasing technology that's been built in. So a user is going to connect to Storefront. Storefront talks to the delivery controller to get a list of resources. In order to do that, it talks to the database. So the delivery controller is then going to keep a record of the things, the resources that the user has access. It keeps it in an XML file, a local XML file. But the process from the user perspective is identical. You know, it still works. It's just we're keeping this stuff in an XML file. The user will then be able to launch their apps, connect to a physical PC, a remote PC, or a virtual desktop, or a Linux desktop. Doesn't matter. If the database fails, if I can't get, actually the database hasn't failed. If the delivery controller can't access the database for some reason, the delivery controller will automatically switch over to the local XML file. And then the user can continue to get access to a resource that they've already accessed before. And that's the key there, is that the user has to have accessed that resource before in order for it to be stored in that XML file. And that XML file is only kept for 7 or 14 days, and then it gets continuously overwritten. And this is typically okay. You know, most people launch the same application every day. So after 14 days, losing all that data typically isn't a big deal. But how this now fits in with zones is that I have my 3 different zones set up. If my satellite zones can no longer talk to the SQL database, they will automatically revert back to the XML file, and users continue to access their local resources. As soon as that link comes back up, the delivery controllers will start using the SQL database again to get access. And so if you look at this, you know, from a grander perspective, what you end up seeing is that within a single implementation, you can have a XenApp and XenDesktop sites that spans multiple data centers as well as multiple cloud resource zones. So I can have, you know, be using Azure in the East, Azure in the West, and Azure in Western Europe, as well as it's connecting to multiple data centers, and it's all managed as a single entity. And again, this is very similar to how Workspace Cloud is that in Workspace Cloud you can think of your primary zone being the portion that Citrix is managing. You know, your delivery controllers, the SQL database, the licensing servers. You don't have any resources there. You don't have any desktops or apps, but that's the infrastructure. And then with Workspace Cloud, you will have these connectors to all these different locations that will talk to the control plane and allow you to manage the environment as a single entity. So very, very similar concepts between doing the, you know, traditional XenApp and XenDesktop that we're used to, as well as Workspace Cloud. So let's now move into some of the best practices. So I've been looking at, you know, some of the best practices, and I've been really trying to reinforce some of the, you know, really some of the fundamental best practices and show how these things relate. So look at the first one. For the best user experience, your apps and backend data must be together on a low latency network. It'll work if you have your application. Let's say, you know, you have your application separate from the backend data. The app's going to work, but as the app needs to read that data, there's going to be latency in the app, and the user is going to experience that latency, and it's going to look like the application is slow. So that's why we want the app and data to reside together in the same network. And this goes really in the heart of migrating to the cloud and doing a whole hybrid cloud model. Many people want to go to the cloud. There's nothing wrong with going to the cloud. What we want to look at, though, is which applications can go to the cloud. Honestly, any application can go to the cloud, but you run into issues when you start talking to the security team about can the data go in the cloud, because that's really what's important, the data. So if your data cannot go into the cloud, don't put your application in the cloud, because you are separating the application from the data. Now, there are VPNs, there are different VPNs you can set up within the different cloud solutions that are out there to allow you to bridge the cloud hosting environment with your data center, except the problem is there's latency involved there. That's that's not going to be a LAN connection, a high bandwidth, low latency link. That's probably going to be a low bandwidth or medium bandwidth and a medium or high latency link, so the application performance is going to suffer. That's why you want to keep the apps and the data together. But using this whole, zones, using Workspace Cloud helps manage this, because now you have it as a single entity. Whether you have your XenApp environment, some of your apps in the cloud, and some of them in your on-premises data center, you still manage it as a single resource, as a single solution, instead of multiple ones. Here I have to manage my cloud, now I got to manage my on-premises. Now I might have done this one in I might have this part in Azure, I might have this part in Amazon AWS. It just starts spinning out of control. So doing something like Workspace Cloud allows you to try to combine all these things together into a single solution. The other thing is that when you look at XenApp, XenApp is kind of a unique beast out there that, especially when you use solutions like like Dropbox and even ShareFile, that when you log on, usually it's going to sync everything down. But on a XenApp in a pooled VDI environment, if it syncs everything down and you log off, your environment's wiped away. So that means the next time you log on, everything has to be synced back down again. And I know my ShareFile directory, it's a couple gig in size. I'd hate to have to download that every time I log into a virtual desktop every day. So with ShareFile, they have this whole thing called OnDemand Sync, where you actually see the files and folders locally, but nothing's there. So when you double-click on a file, it streams it down, from the cloud to your local XenApp server so you can launch it. Of course, there's a little bit of a delay because it has to sync it, but then since it's local, it's then accessing the file locally now, and the performance of the application is fine. And then when you close the app and the file shuts down, it gets synced back up into the cloud, just like it should be. So you got to be cognizant of those type of solutions that syncs everything, because it's going to overwhelm your network, your storage of your environment. The next thing is you need to optimize, but you need to optimize appropriately. And that's why we did all these different tests of optimizations, of not just seeing how many users we can get on a XenServer or Hyper-V server by optimizing the hell out of it. It's going step by step to see, let's do user experience to understand this, let's do optimize with the OS being optimized as well, and see what happens. Because you probably don't want to do everything, because optimizing impacts the user experience. It impacts the functionality you get. But the density numbers you get are impressive, especially on Windows 7. So I'm not telling you don't optimize. It's optimize appropriately. Figure out what your users need. If they don't need the perfect user experience, don't give them the perfect user experience. Give them the scale policy. If they don't need search, shut off search. They don't need if they don't need it, don't give it to them. But if they do need it, then you've got to leave those services running. You can't just shut everything off. So it's kind of something you have to look at and understand what your users require. Now, there's a lot of optimizations you can do, and we've released, Citrix released Windows 7, Windows 8. I've got blogs out there in Windows 10. Basically, they're all the same. Shut down some services, adjust frame rates, change the schedule tasks that are happening on the system. And it's just doing that for the different operating systems. The other portion is path optimization. So this will make sense, when I talk about path optimization. But let me show you the results first. So before, I call this, I guess, version 1. We had the Citrix optimization pack for Link. And the point here was that I can run Link in a XenApp and XenDesktop environment and have a great experience without significantly impacting the CPU of our hosting servers. And so that's what you're seeing, your native ICA on the left versus Citrix with a link optimization pack. 40% versus 1%. And even the quality on both is really good, but if you look closely, you see a crack in the windshield. On the native ICA, you don't. And you look at the billboard across the roadway there, you can see the optimized is more clear than the native, but the native works really well. And so the full video is on YouTube down there you can look at. So, this is a great demonstration, but are we really competing against Citrix? Should Citrix be looking at, how do we make Citrix better than Citrix in the past? Of course we are. But really, when you go to virtual desktops and XenApp and XenDesktop, what people are comparing against is the traditional PC. They want the experience that's going to be the same, that they don't have to relearn things. And in the first version here, what you see is the buttons are different on the screen. There are no buttons on the native ICA, and now there's a bunch of buttons on the link side of things, the optimization side. So the user experience is different. So with the real-time optimization pack for Skype for Business, the focus was still on the user experience, but not only on the video quality, but also on the UI. So the UI, we have the same buttons. So there's no new user training that has to go on with this type of a solution. And again, the performance is what we expected, what we got before. Instead of having like a 40% hit on our CPU when it's virtualized, when you go with the optimization pack, it drops down to about 1%. And how this all works is where the processing is happening. So when you throw VDI in the mix of a Skype for Business implementation, what ends up happening here is that users connect to your virtual desktops over ICA. On the virtual desktop, you have Skype for Business. That will talk to the Skype server and initiate a call with the SIP protocol. So it's going to initiate that voice and video call. The voice and video, the media is going to be transmitted between the different Skype clients on your virtual desktops, and then that must now get processed and sent down via ICA to your endpoint. So again, when you have this voice and video happening on your virtual desktop, the virtual desktop servers have to process that data. And as we saw, that's a 40% hit on a dual virtual CPU system that we tested this on. So with the optimization pack, the real-time optimization pack, the architecture is the same, except we have a media engine on the endpoints that will use the voice and video. It's going to encode and transmit the voice and video and bypass the ICA, bypass our virtual desktop. So Skype for Business is still installed in our virtual desktops. Our virtual desktops are still initiating the call, but once the call is established, the actual communication happens between the physical endpoints. So you end up getting an experience that's the same as a native PC because we bypass the extra hops. And that's why I say it's path optimization, because originally, if we go back, you're going point to point to point to point, user to VDA to VDA to user. And with the new optimization pack, it's point to point, and you're going user to user. What we also saw in this is not only did the performance get better, but the quality got better as well. So as our network decreased, latency increased, and packet loss increased, we were able to use the optimized for longer than we could if we just use standard ICA. So we ended up getting a better experience when we virtualize it. The other thing we can take a look at too to also give yourself better performance, this is optional of course with NetScaler SD-WAN, is that if you have multiple network connections and multiple network links going between two sites, you can create a virtual WAN that combines all these things together. NetScaler will duplicate those Skype packets across those multiple sites. Whichever packet gets there first is used, the other one is simply discarded. So it's basically a race. Whoever gets there first wins, and that's the packets we will use. So it ends up giving you a better user experience. So the next thing, I believe this might be one of the last sections, is IOPS, and I tell you, I'll always present this because I think this is just great technology. Looking at IOPS, disk performance across the different hypervisors when we use XenApp 7.6. And we actually need to update this for 7.7 because there's been some enhancements to PVS that makes us even better, especially on the Hyper-V platform. But what you end up seeing here is that the RAM cache, the RAM with overflow significantly decreased our IOPS, down to about 1 IOPS on Hyper-V and XenServer. When we look at XenDesktop, the exact same thing, except now instead of 10 to 12 IOPS, we're at less than 1. I believe this was, when we did this, it was about a half an IOPS per user. And again, it's like, okay, you're lying because these are averages. And yes, you can easily lie with averages. So we looked at the performance of a single session, a single XenDesktop session, and the actual results. And we saw it was a peak of 12 IOPS for one user, and that was logged on. That was their absolute peak. Everything else, their next peak was, 4, and then everything else was like below 2 for the most part. So the average was a half. If we looked at an entire server, 100 users on a physical server, what we end up seeing for the life of all 100 concurrent sessions was the absolute peak was 155 IOPS, something that a single 15,000 RPM disk can support. 155 IOPS total for 100 users. And of course, you could divide that up, and divide that across 100 users is 1.5 IOPS per user on average. But again, a single disk could easily support this with the RAM caching. And again, this is a lab environment. So I was really happy when a customer implemented this and sent me this graph. And he said I could use it, I just can't mention the customer name. So this was their production LUN, and they turned it on. They turned the PVS RAM cache on. So they were using PVS with disk caching, and they flipped it over to RAM cache. And it's pretty obvious where that happened. Right around April 18th is when they started, or April 16th, 18th is when they started converting things over. Significant decrease. I mean, they were stunned. The other thing we also noticed is when we recorded a video on this, because this was just too good to keep quiet, so we did this whole video on it, that not only did the IOPS decrease, which we already knew, but the performance of the user sessions improved because the storage couldn't keep up for this type of implementation. We weren't doing anything crazy. We're just navigating web pages, and we're just navigating Citrix.com. And what happened is because the storage couldn't keep up, the storage queue depth would increase, and then everything just became delayed and eventually stalled in the browsers. So this type, storage optimization isn't just about reducing IOPS, because not only does that reduce IOPS, that reduces your costs, but it also improves the whole user experience. So if you haven't taken a look at it, hopefully you have, because I've been talking about this for over a year. It's a great technology and just keeps getting improved. So it's a good thing I'm almost done, because I've actually gone over my 30 minutes, I think. So quick summary, optimizations, use them appropriately. Keep your data and apps together. So when you're designing and you're trying to figure out how to do certain things, especially if you're going to the cloud, ask yourself, can I put my data in the cloud? If you can't, then keep your application on premises with your data. If you can, then you can move it into the cloud. There is an appropriate deployment option for every organization. Whether it all depends on what you want to manage. If you figure out what you want to manage, do you want to manage the user rights assignments? Do you want to manage hardware? Do you want to manage the infrastructure? It will guide you into the right path, the right approach for your organization. If you run Skype for Business in an RDS and VDI environment, you need Citrix. Brad Anderson of Microsoft has stated this publicly on Twitter during our summit kickoff earlier this year. IOPS are no longer a roadblock. They haven't been for a while with the PVS RAM cache. So if you haven't taken a look at it yet, I urge you to set it up in a lab environment. Test it out and see what performance improvements you get. I'd love to hear it. When you hear people talk about the HDX codecs, and they talk ThinWire, they talk FrameHawk, they talk H.264, they're techies. Businesses don't care about that. What they care about is the use case. I have a user who, a remote user who is on a satellite connection. Can you support this? Yes, easily. And here's how. There's policies for that. Basically, HDX can handle everything. And just so you know, if you like if you like the diagrams and the images that are used, like for the stencils, there are Citrix Visio stencils that I've maintained on my website. Actually, I'm planning to release a new version next week that will include some of the newer technologies that will be coming out, that are more integrated, like AppDNA, AppDisk. And surprisingly, I didn't even have a stencil for provisioning services, so I've got one in there now, which I'll be releasing hopefully by next week. And that is the end. So I'm gonna keep it on the ending slide there, and I'm gonna start looking through the list of questions and see what I can answer. All right. Not able to hear the presentation. Well, I can't help on that one anymore. Cache and RAM with overflow to disk needs to be supported on MCS. You will get no arguments from me on that. So part of that, I don't have the slide in here, but I do have a slide that I use when I on different times, that there is the read caching capability with using XenServer and MCS. So it's the beginning of this whole caching capability. It now does read caching. So PVS, of course, does read caching and write caching. MCS also does read caching when you're using XenServer as your hypervisor host. Let's see, what else do we got here? Some of the improvements that was done with PVS in 7.7. So there was again, support for Windows 10, UEFI, secure boot support. The big one, though, I believe Dane Young put a great blog out about this, is that PVS now uses VHDX instead of a VHD virtual disk format. And I don't know the exact numbers that Dane put out there, but it was impressive. It was basically decreasing IOPS, increasing performance. It was like everything. So take a look. I believe it's Dane Young. So Google Dane Young and Google like Dane Young provisioning services, and you'll probably get his blog. It's a really good read to look into some of those things. Optimization pack on XenApp, if business just use it for messaging or occasional screen sharing. Do you need the optimization pack on XenApp if businesses just use it for messaging or occasional screen sharing? No audio or video required. No, you don't. It is for the voice and video. That's what it's going to be optimizing. If you're just doing screen sharing, I don't think you'll see much of a difference there. Does the HDX legacy mode in 7.6 feature release 3 also support 2012 XenApp Server? So I didn't touch on that. So when we went through the different policies, we talked about scale, we talked about user experience. When you're in the policy templates, what you end up seeing is one will say optimized for user experience, and then there'll be another one called optimized for user experience legacy operating systems. It's because Microsoft changed the way that they were doing graphics within the environment. So what Citrix was able to do back in Windows XP and Windows 7 no longer worked in Windows 8 and Windows 2012, or Windows 8 and Windows 10 and Windows 2012. So XP, 7, and 2008 did graphics one way. Windows 8, Windows 10, and 2012 did graphics another way. So if you are starting with those template policies, you need to make sure you pick the legacy OS or the normal OS. And it doesn't even say normal OS. It will just say optimized for user experience or something like that, and it'll say optimized for user experience legacy OS. And so those how you will do it. So if you're doing 2012 R2, there is an optimized for user experience. There is an optimized for scale. They do use the new ThinWire protocol that was released within the latest release that had a significant improvement in user density as well as user experience as well as bandwidth. It kind of hit all three things at once. So use the policies and remember and align those with the operating system that you're using. So 2012 would not be legacy, it would be the new one. Let's see. For Skype optimization, will you still get optimizations between a user on a VDA to a user on a native PC? You know what? I would think so. I'm not 100% sure. But you know what? That is a good thing for me to find out. I know who to ask to. So if you're not on, when I find that out, I'll probably tweet it. I might blog it too. That might be a good blog topic. Glad we have video. Well, thank you. Let's see. Questions on NVIDIA virtual GPU. We haven't looked at it yet. It's on our list. There's a lot of things on the list, unfortunately. So no idea when we'll get to something like that. But yes, I mean, it is something I would like to see as well. Bare metal versus hypervisor. So it's been a while. We have done tests with XenApp on bare metal versus XenApp on hypervisor, and we have, of course, bare metal is going to give you the best density. What we end up seeing is about, regardless of hypervisor, whether it's vSphere, Hyper-V, or XenServer, you're going to lose maybe about 5% of density. And I had a slide on that earlier when I talked about the whole NUMA architecture and how to size XenApp VMs. And bare metal, of course, was 100%. And when we sized NUMA appropriately, we were around 95, 96, 97%. So we got pretty close to bare metal. So, you know, it's still things, you know, I always like to go back to bare metal as well just to revalidate, is virtualizing XenApp still valid? Historically, it was when we were looking at 32-bit operating systems. But then, you know, when we got to 64-bit operating systems, it becomes a bigger question: is it still valid? Is it still a valid approach? And you know, you kind of look at that, and you know, personally, from my perspective, is virtualizing makes things easier from a supportability perspective, meaning that I can move VMs around. I can't move a physical server around nearly as easy as I can a VM. And so I think that's kind of one of the big benefits we still have on the virtualization side. Why does the PVS RAM cache overflow for IOPS with XenApp on VM doesn't improve that much? So I don't know. We've done that test numerous times, and it doesn't make any sense. So the IOPS numbers I showed Hyper-V with XenApp had a huge benefit with PVS RAM cache. XenServer with XenApp had a huge benefit with PVS and RAM cache. vSphere had a smaller improvement. And we did this with vSphere 6 and, well, the reason before that, 5.6, I think. And we saw the exact same thing. We did the test numerous times. We rebuilt the environment numerous times. And for all these environments, we left the default configs. We didn't try to go and tweak XenServer so it would be the best, or Hyper-V so it would be the best, or vSphere. We left the default installed. So there might be something in that. But what still doesn't make sense to me is that use the same hardware. We did the same test with XenDesktop, and we saw the benefit on vSphere. So to this date, I don't know why we don't see the IOPS improvement, as much of an IOPS improvement on vSphere. I've had other people tell me who've done it on vSphere have seen the benefit. Our lab testing didn't show it, but other people have seen it. Let's see. Let's see, here's one. PVS 7.7, so there's, oh yeah, I forgot about that feature. Elimination to reverse image. So with PVS, one of the annoying things, you know, I love provisioning services, but honestly, one of the things that annoyed me was that if you wanted to update the provisioning services agent that's on your master image, you would have to go back and reverse image that PVS image. So you basically, instead of taking it as this virtual PVS image, you have to revert it back to a typical VHD or VHDX file that you'd be able to launch without PVS to update the PVS target device software. So you don't need to do that anymore. PVS 7.7 is now able to work around that. But the other part of the question, does this extend to other software that inserts itself into the network stack, such as VMware tools? I do not know, but that is another question that I'm going to follow up on, because I think that's huge as well. I think it fits right in there with PVS, the target device software, because it's VM tools, Xen tools, all those different tools for the hypervisor that have to go in there that will update the network stack. So that's something I'm definitely going to find out on, because that kind of intrigues me as well. Let's see what else. Some of the questions I'm skipping over because I don't know. And again, I'll try to find answers for some of these. Let's see, with zones, can user in zone 1 run apps and desktops in zone 2? Or are they only zoned for purposes for sharing a SQL database? So you can run apps in any zone. Your delivery groups are going to be allocated per zone. But then Storefront will find all the resources that you have access to across any zone. And then you'll be able to access any of those resources regardless of the zone. So zones is really just to help try to reduce the cost of infrastructure so you don't have to have SQL everywhere, because SQL can get expensive, especially when you do mirroring with a witness or clustering or always on. It gets expensive very quickly. Plus it's something more you got to manage. So part of the zones was to get rid of that requirement. The other portion, again, was trying to simplify the management so you wouldn't have all these different islands of deployments around it that you had to manage separately. It became a pain when you had lots of small satellite sites. But when you do zones, everything, you'll be, as a user, regardless of where you're located, will be getting access to an app that's in any zone. Wouldn't it be better if every satellite solution would use kind of a mirrored SQL? So, yeah, so you would have your main SQL like in the primary, and you would have mirrors that would be in each satellite, but they'd have to be read-only mirrors. So what you end up having is that there's still all the writes that has to happen. So with FMA compared to IMA, IMA was the 6.5 and before on XenApp. The database, so with FMA, there's a lot more reading and writing that's happening in the database than there ever was in IMA. The IMA database was much more static than the FMA database was. So all the connections, all your active connections that are stored in the database. So that's why in the FMA database, 7.x, the database size isn't very big, but the transaction log is massive. It's because all those changes, all those sessions, all those connections are transactions that are happening against the database. So if you would have a SQL database in your primary zone that was read and write, and then you had read-only copies in your satellite zone, what I would think would happen is, I don't know if you would gain anything. You'd be able to read pretty quickly, but what you would end up having is all your writes would have to go back to the main SQL, and then you couldn't trust your local SQL until those transactions were actually updated locally. So, if the latency across that link became greater, I think you'd start getting into issues where you would, things wouldn't be aligned very much. And SQL's got things that can handle that stuff, and how they handle the transactions and making sure they've been committed across the different read-only databases. But I think it would just add a little more complexity to the environment. Unfortunately, we are at the top of the hour, so I'm going to hand it back to Brad. I'm going to take a look at the questions I didn't answer or wasn't able to answer and see what I can answer, like maybe in future blogs or videos and things like that. So thanks, everyone, for attending.
Thanks, Daniel. Everybody, thanks for attending the CUGC webinar today. I'm just going to throw up a quick slide here. We'll just go over a few last minute things as we close this out. We'll have more discussion and recording. The recording will be posted at mycugc.org. We're going to do that as quickly as we can to get that up there, especially since several of you had some audio issues today, and we apologize for that. We also have a thread up in the CUGC Hub forum where you can continue discussing today's webinar. When the recording is up, we'll make sure to post in that thread a link to the recording so that everybody knows. Thank you to everybody for attending. You're going to receive a brief survey about the meeting. If you take a few minutes to fill that out for us, it'll help us improve these webinars and let us know exactly what it is that you would like to see from CUGC. And also make sure to check out mycugc.org for information on upcoming webinars. We have a full slate this spring with a lot more announcements on the way. We're excited about it. And if you have any topics or ideas for a future webinar, please send us an email at hq@mycugc.org. Thanks again to Daniel for a great presentation, and thank you to all of you for being here. We really appreciate it, and we'll continue this conversation online. Thanks, everybody.